Hi, welcome to the math stage. In this video, we'll be focusing on scientific notation or standard form. This will just be an introductory video, but more videos will follow on this topic. Before we begin, please remember to like, share, comment, and definitely subscribe. Let's get straight into the video. What is standard form or scientific notation? This is rewriting numbers with a power of 10 so they can be easily worked with. It's convenient for writing very large or very small numbers. The layout for standard form is a times 10 raised to the n power. Where a is any number that is equal to or greater than 1 but less than 10. Therefore, a cannot be equal to 10. N is the power of 10. It is also any integer, positive or negative. And this n tells the number of times 10 multiplies itself. If you're having any trouble working with index notation, you can go ahead and check out our videos on the laws of indices and solving problems using the laws of indices. The links for these will be in the description below. An important note, if the n value in scientific notation is positive, therefore the original number is greater than 1. And if the n value is negative, the original number is less than 1. Let's go ahead and look at some examples. Here we have 360,000. The instruction is to write this in scientific notation. What's the first thing we need to do? Well, we need to write this number as a value between 1 and 10. Now, how do we do that? We'll have to move the decimal point. The decimal point in this number would be located here, behind the last 0. Now, we're going to move this decimal point to the left to get a number between 1 and 10. Let's go ahead and move this decimal point. Remember, we only stop when there is a number between 1 and 10. Now, if our decimal point falls between the 3 and the 6, we end up with 3.6. 3.6 falls between 1 and 10. As such, 3.6 would be our A value. Now, we're going to put back our multiplication sign and the 10. All we have to do now is find the n value. In order to find the n value here, n would be equal to the number of times we move the decimal point to get our A value. So let's count how many times we moved. So we're starting here. So it's 1, 2, 3, 4, 5. So we moved our decimal point 5 times. The next thing we need to know is our n value going to be positive or negative? Remember, if the original number is greater than 1, the n value is positive. Is this number greater than 1? Yes. 360,000, the original number, is greater than 1. As such, our n value is positive. So our final answer in scientific notation or standard form is 3.6 times 10 to the 5th power. Let's look at another example. This time we have 43,000. First thing, we have to write this number as a value between 1 and 10. How do we do that? We move our decimal point, and in this case, we'll be moving our decimal point to the left. Let's go ahead and move our decimal point until we get a number between 1 and 10. So the decimal point would be here behind the last 0 in 43,000. Let's move. If our decimal point falls between the 4 and the 3, we end up with 4.3. That is between 1 and 10. As such, 4.3 would be our A value. Now, let's put back the multiplication sign and the 10. We now need to find our N value. How do we find the N value? The N value would be the number of times the decimal point was moved. Let's count. Starting here, 1, so this would be 0 because it wasn't moved here. So 1, 2, 3, 4. We moved our decimal point 4 times. But is it positive or a negative 4? Well, just looking at our original number of 43,000, we can see that it is greater than 1, and thus our N value would be positive. So we end up with 4.3 times 10 to the 4th power, and that would be our final answer. At this time, we have 0.0000036. The same thing applies here. We need to get this number as a value between 1 and 10. What do? That is right, move the decimal point. We can clearly see that our decimal point is located here. So for us to get a number between 1 and 10, we're going to have to move our decimal point to the right. Let's go ahead. And if our decimal point falls here between the 3 and the 6, our A value would be 3.6. We put back the multiplication sign and the 10. Now for us to find our N value. We already know that N is equal to the number of times we move our decimal point. Let's count. 1, 2, 3, 4, 5. Now the next thing we need to know, is this N value positive or negative? Well, since our original number is less than 1, 0.000036 is less than 1, our N value will be a negative value. So it's going to be 3.6 times 10 to the negative 5. If we had 0.007601, how would we write this in standard form? Simple. Get a value between 1 and 10. Let's go. Decimal point here. Let's move to the right. 1, 2, 3. And if our decimal point is between the 7 and the 6, we end up with 7.601. And that would be our A value. We put back the multiplication sign and the 10. Now to find our N value. How many times did we move the decimal point? 1, 2, 3 times. And since our original number is less than 1, it is a negative 3. So 7.601 is our A value and the negative 3 is our N value. So we have learned how to convert to standard form. Let's learn now how to convert from standard form. Now, our first example, 3.5 times 10 to the 3rd power. When converting from standard form, if the N value is positive, the decimal point will move N places to the right. And if the N value is negative, the decimal point will move N places to the left. The instruction here is to write as the original number. In this instance, our n value is 3, and the 3 is positive. Therefore, we are going to move 3 places to the right. Let's go ahead. So if we have 3.5, let's move 3 places to the right, this way. Let's go. 1, 2, 3. And we're going to fill these empty spaces with zeros. So final answer will end up being 3,500. 9.72 times 10 to the 4th power. What is our n value? Our n value here is 4, which is positive. When our n value is positive, we'll move n places to the right. So here we're going to move our decimal point 4 places to the right. Let's go. 1, 2, 3, 4. Then we fill the empty spaces with zeros, giving us an answer of 97,200. Let's look at 2 more. This time we have a negative n value. Our n value is -5. And if our n value is negative, we'll move our decimal point n places to the left. .88. Let's move our decimal point 5 places to the left. 1, 2, 3, 4, 5. Our decimal point would end up being here. Let's fill these spaces with zeros. And let's also put a 0 here before the decimal point. What are we left with? 0.0000888, and that is the final answer for this one. Let's look at another one. (8.1 times 10 to the -2). The n value here is 2, which is negative. Therefore, we're going to be moving our decimal point 2 places to the left. Let's go ahead and do that. One, 2, point here. Fill this space with 0 and put a 0 before the point, leaving us with 0.081, and this would be our original number. Comparing numbers in standard form, we compare the powers of 10. The greater the power of 10, the greater the magnitude of that number. If, however, two numbers have the same power of 10, we compare the A values. If the A value is greater, the magnitude of that number is greater. Let's compare and order these numbers, starting from the smallest to the largest. The lowest power of 10 here is -6. As such, 7.05 times 10 to the -6 would have the smallest magnitude. Which would come next? 5 times 10 to the -3. Followed by 3.5 times 10 to the 0 power. Our last two numbers both have a power of +3. Therefore, let's compare the A values. The greater A value is 4.09. So this would be the greater among the two. So we would put 3.5 times 10 to the 3 here. And the greatest would be 4.09 times 10 to the 3rd power. We have come to the end of this video. Thank you guys for watching the math stage. Please remember to like, comment, share, and definitely subscribe. And remember to watch the videos that are linked in the description below. Until next time, bye for now.